As I said, welcome everyone. Welcome to today's lecture. I'm Mahmoud Mohammed Jibril, the CEO of S.A. Design Consult. Uh, no, not on the WhatsApp page. I send it to the Zoom lecture. You will see the link to there in order to fill all your informations. I'm Mahmoud Mohammed Jibril, the CEO of S.A. Design Consult. I'm the one that will be taking you this lecture on how to do the design of an IC beam to BS8110 in Tekla text. So many people were asking, what is a Tekla text? What is the difference between them? Although some of you don't know what is a Tekla structural designer, in Tekla or in Trimble company, they have three softwares, in which one it is the Tekla structural designer, two it is the Tekla structure, three, it is a Tekla text. Each software, there is what you are going to do with it. Each software has its own application, importance, and so on. So Tekla Structural Designer, it is a BIM application like Prota, Orion, ETAPS, Quicksilver Series, Robot, SAP, and other BIM application softwares. Where Tekla Structure, it is a software for modeling like Revit structure in order to fabricate and so on, detail structural members manually the way you want the structural member to be. And Tekla TEDS, it is a software for generating report of structural members for like, oh, you can use such software in order to check your analysis and then the design that you perform with other BIM application software. That is the application or the importance of Tekla heads. Normally, most of our consultancies here in Nigeria, or let me say most of the consultancies in Europe, America, especially in America, they were using Tekla TEDs in order to generate a report for their design that they did. So without the waste of much time, I will share my screen for you in order to start demonstrating on how you are going to go, how you are going to work with such a software. I'm going to share on my screen for you. I hope you have started seeing the screen. So now I'm going to launch the Tekla text and going to show you how to start a new project and how to choose the template and how you are going to work with each and other templates of such Tekla text. So without the waste of much time. So what you are going to do, if you have the Tekla text here on your system, I'm coming, I just want to remove this one. Good. So what I am seeing is that if you have the Tekla text on your desktop automatically, you can just double click on it. So you cannot see even the software here. I have my softwares here. So I will come as I have opened the Tekla text automatically. So I will close on it in order to show you how to start working with such Tekla text. So when you come, you will just double click. This is the Tekla text. A dialog box will appear. So when the dialog box appear, you will see Tekla text. You will see TED for words. And these two plugins, each of them has its own importance, has its own application. The Tekla text, it is to work inside the environment of the Tekla text, and the Tekla for Word, it will launch Microsoft Word for you. After it's launched the Microsoft Word for you, you will see the plugin of the Tekla text inside, then you will work with it. I know some of you who are doing programming, who are the civil engineers here doing programming, you will understand what I mean much more by using the plugins in the software automatically. So I'm going to choose the first one, that is use the extensive library of calculation recommended for new users. This one, it is use the extensive library of calculation to create complete project reports or written your own custom calculations. So I'm going to use the first one in order to show you the dialog box, the user forms, or the calculation forms of doing such types of the design. That is a single member, or you can work with a multi-members, that is a beam which have more than one span, even 2, 3, 4, up to n numbers. So I'm going to choose the first one. When I click on the first one, I will exercise patience. It will open for me. So it is launching. I am using Tekla 2021, or if you are using lower version than mine, it is all the same. Just know the procedure of doing such. So it is opening. We should exercise patience. When it's open, another dialog box will open again, in which this is just a message or a prompt message that will open for you. So if I like, I will close this one. I will just click there automatically in order to close such. So now I am going to start a new project. So if I am going to start a new project, I will just click on new tab here. When I click on new tab, a dialog box will open for me in order to choose which template am I going to work with it. It is either EN code, EC, or ACI, or IS code, or BS code, and so on, or GB, that is Chinese codes, and so on. So now it depends on which type of member. What am I going to do with the Tekla text? Am I going to do analysis, batch design, beam design, column design, composite design, concrete, or the connection, drainage, earthworks, Eurocode, flows, foundation, highways, loading, mansries, and other types of design that you are going to do with the Tekla text. So now, and the purpose of this lecture, we are going to use the concrete. You will come here and double click on the concrete. When you double click on the concrete, so many information will come. These are all the libraries that we have for the calculations in order to do calculation based on concrete members. So now I'm going to use IC-BIM. I'm going to work with IC-BIM. You have IC-BIM analysis and design. First thing, what the software will start doing, it will analyze the BIM, then it will design the structural member. Although when you are working with other BIMs application in which like proto structure, if you are working with it, on the last lecture that we conducted, we go into one a stupid structure, remember, that is the beam in which it has too much reinforcement and it's almost up to 10 y16. So we now decide to increase the thickness of the structure, remember, without the analysis being expired in portal structure. So we did such, we conducted a lecture such, and so many people see. So it's the same thing that we are going to do here. What we are going to do here, only we want to give the software the information that we want in order to analyze the structural member for us and calculate the number of reinforcement for us. So when I double click on the IC beam design to BS8110, I will click on the first one, that is IC beam design, not single layer example, not two-layer example. These are all examples of how we are going to use this template. I will double click on the first one, then it will launch for me. It will open. This is just the report sheet, but the calculation sheet will open automatically in order to give information to the software. Then if I am giving the information to the software, it will be calculating it automatically within some few seconds. Those of you who are relevant to Excel, those of you who are much more familiar with Excel BVA knows how to do this kind of things. So this is a dialog box that will open. Normally on default, you will see a rectangular section. So here, if you get the information, BIM analysis result, what it means here, it needs you to give her the moment that is acting on such structural member. Whether you are working with a flange section or you are working with a rectangular sections. If you are working with a rectangular sections, automatically it is on a rectangular section. You can zoom here, zoom in and zoom out. You can do such as it is in the other BIM applications. So assume we have the moment, or we can, just a demonstration. All of us here, we are structural engineers. We are doing the practical work. We know how to do the analysis and how to obtain the moments and so on. If we have 150 kilonewton meter on the moments, then it acts as momentary distribution. Those of you who are good in analysis or who have gone far in analysis and then the design of structural members, they know what is momentary distribution. Momentary distribution, it is a method of reducing a negative moment and increasing a positive moment. That is to say that since compression, since hugging moment, it is acting in compression, or compression are subjected to support, sorry, are subjected to compression. So normally we are reducing the moment at the support by some certain percentage in order for the moment at the midspan to increase. That is the percentage of moment redistribution here, which is depends on the number of story, but we are not going to cover it here actually. So I will choose 5% just to go with 5%. So here it is the shear force that is acting at the support of such structural member. The shear force that is acting at the support of such structural member, after your calculations, then you will know the shear, assume we also have 150. After such, this is the top reinforcement. Then the top reinforcement means the reinforcement at the compression phase of such structural member. And if you have too much, or the beam, it is very, very thick enough, normally, you are not going to go with a single layer. You can go with a double layer at such position. Or since we have a larger moment, we have 150 kilonewton meter, we are going to go, let us say the number of bars, we are going to go with 2. Then the diameter of the bar, we are going to go with 16. That is Y16 at that position. If we have multiple layer of the reinforcement, I will click specify multiple layer here. Then the information here automatically will change. It will say layers. When you click on the layer, a dialog box will open also. This is the number of layer. Default it is 2. Maximum it is 4 layers. When I click on 2, number of bars in the first layer 2, diameter 16. If I have another bars in the second layer, I will go, assume I have 2, and then the diameter is, let us say 12. When I click on OK, the information here in this diagram will automatically change from the software. You will see it will change automatically. If you zoom it, you will see the information it is changing at that positions. You will see the information. You have 2 reinforcement here, 2Y16 and then 2Y12. But if I am not going to go with 2 layers, with 1 layer, I will uncheck the box. It will automatically return 1 layer for me. So after such, what I am going to do at the bottom span reinforcement, you as an engineer, or you as a structural engineer, you will know like a certain moment will require at least, let's say, so some certain number of reinforcement at the midspan of such beam. So like 150, I know if I'm going with Y16, it will go almost up to 6Y16 because it's a rectangular section, which is the one which is not, or which is not the flange section. It is more economical than a rectangular section. If it is a flange section, assume it is beam or L section, it might be just 4Y16 or 5Y16. Because it is a rectangular section, you might have too much reinforcement at that position. And then I'm going to go with Y16. And if I go with Y16, you'll be seeing information here will be displaying saying longitudinal reinforcement is too widely spaced at this position. Here it is X automatically. And if you saw here, area required is 427, and the provided it is 335 millimeters square per meter. How can you correct this kind of errors? So what I'm going to do here, if I increase, I say, let us go to 4 reinforcement, you will see area required is 859 millimeters square. And what we have provided, it is 804 millimeters squared. If I go with 5, then here it will say area required, it is 859 millimeter, and this one provided it is 1005 millimeter square at this position. Then the bottom reinforcement is satisfied. But here, the section of such structure, remember, depend on which section that you have on such structure. Remember the dimension of the cross section. I mean the width and the thickness of the structure, remember. So if I am going to edit such, I'm going to set my concrete cover, durability of fire resistance, shear links, and so on. I will click here beam detail. If I click on beam detail, it will automatically open. Here stays standard fire resistance. Default, it will come 1 hour, that is 60 minutes. So if that is beam exposed to fire on 3 side only, that is, you can check here if it exposed to this place here and here also, or any kind of place of the beam. Then beam geometry, if I am going to go with rectangular section, I will click. But if it is T section, it will change automatically. L section, it will change automatically when you click on, but we are going to go with the rectangular section. And then the width of the section, I'm going to go with 9" 225, and then depth of the section 450 automatically. When I click on enter, it will return to this dialog box, and I don't want her to return to this dialog box. Then beam detail, I will come back here again. Don't click enter. Come here and set your concrete class. I'm going to go with C25. Here it is our concrete cover. I'm going to go with M25 millimeter, 25 millimeter. This is the density of the concrete. The characteristics hill strength of the reinforcement, I'm going to go with 410, that is type 2 deformed bars. And I'm going to go with another 410 as the characteristics hill strength of the shear reinforcement. And then the maximum aggregate size, which is 20, and then I will click on OK automatically. When I click on OK, you will notice something here says longitudinal reinforcement is too close space. Those of you who have sent the message, I will go to the message. They say longitudinal reinforcement is too closely spaced. So what we are going to do is to increase the number of layer of such reinforcement. I will click here on this box. The information here will change automatically. Then I will click on layer. If I click on layer, number of layer 2, number of bars in the first layer, I will go with 3, then Y16. Then number of bars at the second layer, I will go with 2. Diameter, I will go with 16 also. Automatically, all of them will give us a 5Y system. But if you check here, area required, it is 1383 millimeter square, and the provided it is 1005. Then I will increase here again in order to see. Then the number of bars does not satisfy or will not be okay at such structure, remember. Also, I will increase this one to 4. When I increase it to 4, at the first layer, I have 4 reinforcement, and the second layer, I have 3. Then the area provided is okay, and I will click on OK. But if I am going to set the spacing between the vertical spacing between the reinforcement, means the vertical distance between the horizontal bars, which is the minimum, it is the size of the aggregate plus 5 mm, which is the minimum of such longitude, such vertical spacing of horizontal bars. So here I am going to go with the aggregate size, which is 20, then plus 5, it is 25. That is the minimum. I can go with 30 and then click on OK. If I click on OK, it will update everything here. You will see, as you are seeing here, we have 4 and we have 3 on such structure, remember. And if you check here, the area required, it is 1430 millimeter square, and provided 1407, then it is not okay. I will click again, and then I will increase this one to 4, then it is okay. I will click again, and then here automatically will be updated. So when I come back to the shear reinforcement, I'm going to go with diameter of shear length. Let us go with 10. Since we have too much shear at the support 150, it is not a small load. So number of legs, we are going to go with 2, and then spacing of the longitudinal spacing of the shear links, let us go with 200. When I go with 200, I have area required is 600, and then the provided it is 785 millimeter square per meter, and then the spacing of the links is okay. And then the maximum spacing of links on a beam, which is 0.75 times the effective depth. So when I finish with this one, everything, all of the information that I gave to the software is okay. And then I have 8Y16 at this section. So if you see the reinforcement is too much on such a a beam, you can increase the thickness of the member in order to reduce the quantity of the reinforcement. So if I click on finish, automatically it will paste everything here for me, including the calculations, the rectangular section detail, the cross section, and everything that I did. In here, you will see pass, area reinforcement, and everything, all of the calculations. So the challenges here is that if you notice that you are going to edit an information which you provided to the software, how are you going to edit such? In order to edit such kind of things, you are going to right click on it, go into calculate. When you click on calculate, everything will come back. It will take the informations again. Here it comes back here for you. Then this output options, if you want to limit everything to be summary and so on, you will click here, say none or summary. If you click on the summary, click on OK, and then click on finish, it will give you the summary of the result automatically. You will see the summary of the result, not too much at this position. But if I am going to go back, I need detailed calculations of such a member, output summary, and then I will click on full, then OK, and then I will click on finish automatically. So this is on how to design a rectangular beam. As I have explained for you, what you will do, let us go back to the calculations in order to demonstrate such for a flange section. When you come back here, change it to T-beam. Here you have the maximum width of the flange. That is the maximum width of the flange, depth of the flange, that is the thickness of the slab. Assuming we have 150, distance between point of zero moment. Distance between point of zero moment, it is when you have the beam supporting two slab. Assume the slab have 3.5 at the left hand side, 3.5 at the right hand side. It will take half of the 3.5 from the left hand side, half of the 3.5 from the right hand side, then add it, it will be the point of zero moment at that positions. So if we have 1 meter here, then we will have 1 meter as the point of zero moment. And then here, the maximum width of the plant, it is when you're going to calculate whether it is simply supported, whether it is rectangular. For a simply supported, which is IZ all over 5 plus width of the beam, and if it is a L section, IZ all over 10 plus width of the beam. But when such structural member is continuous, you will multiply that IZ over 10 times 0.75 plus width of the beam, where the I subscript Z, it is the effective length of the structural member. So this is only the information that will differ from that rectangular section. If you notice, this 3 will go. If you go to flange, this 3 will come back. That is only the difference between them. But we are going to go with the rectangular and then click on OK and then click on finish. So when we are done with this one, how are you going to print your report? If you check here, I have all of my information in the software because I have license with Trimble Identity. Then you will come here and click here. A dialog box will open for you in order to click on print and then print preview. We can go into print preview or click on print. When you click on print, it will ask you this one, Microsoft to this one, or you will click just is okay for you, can click on OK. Then it will ask you to specify a location. I will name it beam 001 in my desktop, and then I will click on save. Then it will print everything for me. Then if I go to my desktop, this is the beam, I will double click on it, and then I will see the reports automatically that is generated by this.